Inspired by the human finger, MIT researchers have developed a robotic hand that uses high-resolution touch sensing to accurately identify an object after grasping it just one time. Many robotic hands pack all their powerful sensors into the fingertips, so an object must be in full contact with those fingertips to be identified, which can take multiple grabs. Other designs use lower resolution sensors spread along the entire finger, but these don't capture as much detail, so multiple regrabs are often required. Instead, the MIT team built a robotic finger with a rigid skeleton encased in a soft outer layer that has multiple high-resolution sensors incorporated under its transparent skin. The sensors, which use a camera and LEDs to gather visual information about an object's shape, provide continuous sensing along the finger's entire length. Each finger captures rich data on many parts of an object simultaneously. Using this design, the researchers built a 3-fingered robotic hand that could identify objects after only one grasp with about 85% accuracy. The rigid skeleton makes the fingers strong enough to pick up a heavy item such as a drill, while the soft skin enables them to securely grasp a pliable item like an empty plastic water bottle without crushing it. These soft rigid fingers could be especially useful in an at-home care robot designed to interact with an elderly individual. The robot could lift a heavy item off a shelf with the same hand it uses to help the individual take a bath. The robotic finger is comprised of a rigid 3D printed endoskeleton that is placed in a mold and encased in a transparent silicone skin. Making the finger in a mold removes the need for fasteners or adhesives to hold the silicone in place. The researchers designed the mold with a curved shape so the robotic fingers are slightly curved when at rest, just like human fingers. The endoskeleton of each finger contains a pair of detailed touch sensors known as GelSight sensors embedded into the top and middle sections underneath the transparent skin. The sensors are placed so the range of the cameras overlaps slightly, giving the finger continuous sensing along its entire length. The GelSight sensor is composed of a camera and 3 colored LEDs. When the finger grabs an object, the camera captures images as the colored LEDs illuminate the skin from the inside. Using the illuminated contours that appear in the soft skin, an algorithm performs backward calculations to map the contours on the grasped object's surface. The researchers trained a machine learning model to identify objects using raw camera image data. As they fine-tuned the finger fabrication process, the researchers ran into several obstacles. First, silicone has a tendency to peel off surfaces over time. The researchers found they could limit this peeling by adding small curves along the hinges between the joints in the endoskeleton. When the finger bends, the bending of the silicone is distributed along the tiny curves, which reduces stress and prevents peeling. They also added creases to the joints so the silicone is not squashed as much when the finger bends. When troubleshooting their design, the researchers realized wrinkles in the silicone prevent the skin from ripping. Once they had perfected the design, the researchers built a robotic hand using 2 fingers arranged in a Y pattern with a third finger as an opposing thumb. The hand captures 6 images when it grasps an object, 2 from each finger, and sends those images to a machine learning algorithm which uses them as inputs to identify the object. Because the hand has tactile sensing covering all of its fingers, it can gather rich tactile data from a single grasp. In the future, the researchers also want to improve the hardware to reduce the amount of wear and tear in the silicone over time and add more actuation to the thumb so it can perform a wider variety of tasks.